Greetings, everyone. What I'm going to show you here is we're going to start out with programmatic I/O, input output. So quite simply put, input output is exactly what you think it is. How do you get, I'm not going to say data, I'm going to say stuff because it can be data. And how do you get stuff into your program and how do you get stuff out of your program? Now, I'm being kind of evasive on purpose here, and let me explain why over the next couple minutes or so. I/O for software is a pretty big topic. For Java or for Python or for any language that you're going to be using, it's a very deep and in-depth topic. And once you get into intermediate programming, you're going to start exploring more about I/O. Now notice I didn't say file I/O or text I/O or any kind of I/O because input and output can be a variety of different things. When we think, non-programmers, when we think of I/O, we think about like reading and writing files. Okay, well that's one kind of I/O, but there's so many other different kinds. Like, for example, for input into a program, it can be, off the top of my head, it can be a file. It can be a data stream from a real, from a streaming website. Like if it was streaming stock quotes, that could be input. It could be text from a program. Most of you have experience using Scanner to get data, typed data, like your, users typing data into a program. It can be another program that's piping output from one program into a next, which is called program chaining. It's a pretty big and deep topic. If you're listening to me from this, if you're listening to the sound of my voice, you're an introduction programmer. You've had between 0 and 3 months of writing code. So we're not going to get into it right here. What I want to do is my objective is to get you comfortable with just some kind of I/O. So you get at least familiar with writing code. I want you to be successful and at least have, a program under your belt without breaking out the conceptual canons. Now, you're going to see in your reading and in your online endeavors, there's a lot more to it. And you're like, well, why didn't Bob explain this to us? Well, because it's really too much. If this was an intermediate programming class and we were learning Java and you had another language in back of you, we would spend a lot of time on I/O. But in here, which is a beginner's class, we're just going to kind of go over the basics with the disclaimer that you just heard over the last 3 minutes or so. So I'm trying to get you to be successful while not trying to overwhelm you and confuse you with things that it's going to take you some time to learn. But let me just start with that, and then we're going to get into the objective today. What I'm going to do in this demo is I'm going to show you how to write a Java program that's going to create a file, which we're going to eventually write to. I'm not going to do that demo in today's demo, but we will at least get the part done where I can show you how to write a file. Now, one thing I want to show you is you see here in my program, you see system.out. Now, this is actually your first introduction to I/O or output in this case. In Java, we have the system class, which you see here to the left. The .out actually also has a cousin or a sibling called in. There's system in and there's system out. System out is what this program is going to write out. Now, again, I'm hemming and hawing because it doesn't always have to write out. It can stream things too. But basically, how about this? This is what can come from this program. In this case, we have system.out println, which, as you probably know by now, simply writes this text, hello world, to the command line, and you see the output of it. Again, tip of the iceberg. Out does a lot more. If you want to take this further, optional for this would be Google is your friend. Google Java system.out, and then you could look at the documentation for the default I/O stuff. You're going to see things called data sinks, streams, input streams, output streams, readers, buffered readers, semi-buffered readers, buffered writers. You're going to see all of that stuff. and you're going to say, holy schmoly, right? I'll be politically correct here. How old are you, Bob? Did you just say schmoly? Okay, but you're going to look at that and say, wow, there's a lot more to it, and there is. In time, grasshopper, in time, that stuff will come to you. You're not going to learn it all in one day. You're probably not going to learn it all in a year, or maybe a year, but it's something that you learn as you go. This is, again, just the tip of the iceberg. Okay, soapbox done. Let's get to it. We're going to write a program here that's going to write a file for us that we're going to eventually, write to. All right, we all know what a file is, right? You get a text file, .txt, and you open it up in Notepad and you do whatever with it. Now, you can write different kinds of files in Java or any different kind of language. So we're just going to keep it simple, and we're going to write text files. Now, if you wanted to, it doesn't even have to be local. You could write the file as part of a URL if you have access to a share on a web server and you wanted to write that file or read it. You could do that as well. Again, tip of the iceberg. We're going to keep things simple for the 50th time, Bob. Let's get going, right? All right, anyway, so let's go and talk about some I/O with writing a file. So first what we need to do is we need to import something. Now this might be new to you because, again, I'm thinking that this is your first program that you're going to be writing. Let me give you a second and ignore that. Just pretend you didn't see that. Those are my notes here. Okay. Let me do the following. In line number 1, let me type in import java.io .file. And then also, I will do the following. Import java.io sorry about that. My keyboard's a little bit funky. Java.io .io exception. Now let me explain to you what these are from the perspective of a beginning computer science student. That's what you are. So I'm going to get away from just the recipe here and get into a little bit of backstory here. Java is a very small language. There's very little to it. I mean, Java as a language is very, I think the word succinct, I don't know. It only has very few things in it. It has, the syntax, that looks at the blocks that you have, make sure you have a main method, make sure you have your class, all the stuff that you might be used to by now. But there's a lot of extra stuff that you could use in Java, and these are called the Java packages. What you see here in Java, in line number 1 and line number 2, is this might be your first opportunity that you see the import statement. Core Java, like I just explained, is very small, but if you include all of the packages, it's huge. It's almost like this. It's almost like if you... this is probably a good example. If you bought a video game and then the video game had a lot of extra stuff, different levels, different characters, different icons, different stories, different everything, but you had to add them a little bit later. That's kind of how Java works. And as a matter of fact, that's how most languages work. Well, actually, almost all of them. I'm trying to think of one that really kind of doesn't. But most languages are really small, and then if you want to use extra stuff, you have to import them. Now, the concept of importing is kind of the same in each language, but the keyword might be different. In Java, we use the word import. In C and C++, it's like include. And then if you're doing .NET, like C#, it would be using. But the concept is the same. If you're not using just the core language and you need extra stuff, you need to import them. So what do you know that you're supposed to import? Well, believe it or not, you're going to learn this as you go. Knowing what you need to import, you learn as needed. It's almost like when you read a map. You don't need to memorize the whole map. You just have to look at where you need to go and get what you need just for that. That's how packages work. In this case, I'm introducing you to two different imports. I'm introducing you to the file and to the IO exception class. Now, file is a file that you can write to your local system, your, whatever it may be. Now, I realize it's going to be different depending on your architecture. If you have a Windows machine, it's going to be in a folder. If you're in an Apple, it's going to be somewhere else. Blah, 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 blah. I get it. And you're going to have to learn the differences between those eventually. Today, you just need to know what a file is. Also, you have here on line 2, something that's a little bit different and something that's going to be a challenge for me to kind of explain to you, because this is kind of a whole new world here, something that you probably have not been exposed to. You have what's called an IO exception. So there's two things that I need from you. One is everything I'm going to tell you in the next 2 or 3 minutes about IO exceptions, you can safely park in the back of your brain for now and say, you know what? Okay, I don't need to completely understand this, but I'll need to understand this someday, because that's what this is. Okay, here it goes. Exceptions, as you see here, on line 2, are different runtime errors that can happen in the execution of your program. Now, exceptions again are the things that could go wrong while you're running your code. You probably have seen them if you've worked with integers and floats and all this other good stuff. When you ran it, you might get an error saying, "Oh, you can't do this. This is a lossy conversion error," or "Can't put this data type into this one," or whatever. But you've probably seen runtime errors at this point. At this point. Now, again, a runtime error in software is called an exception. We call those exceptions. Now, here's the good part. Exception and the term exception exists in almost every language. So when we talk about exceptions, we talk about runtime errors that happen when you're running your code. They happen in Java, Python, C#, Ruby, name it, there they are. They're called exceptions. So when we're writing code, we need to know what an exception is. And again, this is another whole universe here. And we also need to know how we handle them. What do we do when there's a runtime error? Do we fix it? Do we send the user a better message? So rather than saying lossy conversion error on line 85637B, maybe we send the user a better message, or we generate a better message saying something like can't convert a string to an integer. Anyway, how we handle that runtime error is called exception handling. So we have exception, which is the runtime error, and we have exception handling. This is what we do as a software developer with the runtime error. This is something that's going to be in your intermediate coding course, because again, this is crawling down the proverbial rabbit hole. As soon as I start opening up that can of worms, it's hard for me to kind of know, as a doctor of computer science, where to stop with it. So what I do is, for the beginners, us, this class, or whoever's listening to me, is I keep it simple and I say, this is something you're going to do later. Just get the concept for now. Exception, runtime errors, exception handling. What do we do when something bad happens? And that's what you see on line 2. We're going to be handling an IO exception. Like when we write a file, what if it doesn't exist? What if it already does exist and we need to write over it? These are all runtime errors that can happen, and these are errors or exceptions that we need to handle. A lot of explanation there for one line of code, huh? All right, anyway, enough. Let's go. All right, so let's do the following. We're going to write the code to create a file. So I am going to write the code to do that. And let's get rid of this hello world. We all know what that means by now. Even though technically this is IO, so we can leave it, but we're not. We type in the following: file, and we'll put in at my obj, we'll call it my object, right, equals new file name, and we're going to call this one, I will put in Bob, right? So you know it's really me. .txt. Now, let's talk about this syntax a little bit. First of all, what this does is this creates a new file class. Now we have to go into the abstraction, and I got to unleash the conceptual cannons on you. We're not really creating a new file on our drive yet. We're almost doing it. What we're doing here is we're declaring a local variable of the type file. Now, this might be new because you know what a variable is, right? You've probably at this point have used integers, floats, longs, decimals. Okay, those are actually called simple data types because they hold simple things, right? They hold numbers. File is really a different kind of data type. It's called a class data type. It's not a simple one. It's a file. It's a little bit more complex. So just know that there's simple data types and there's more complex ones. So like a file would be a complex data type, but otherwise the naming is the same. We're going to call this one my obj, which is my object. We could have called it Mary Had a Little Lamb, and we're creating a new file called this. Now, later, you're going to kind of go into the syntax here because this is kind of important, what's happening on line 7. New means we're creating a new instance of something. Now, when you go into OO programming, right, they're going to talk about, or maybe me, we're going to talk about classes and instances of classes. And that's what you see here for 7. Again, you could put this on the back burner and know that this is going to be explained in a lot more detail when you talk about object orientation. Okay, what this is saying here is you're going to build a file called myobj, and you're going to create a new instance or a new one, bob.txt. This is how I explain this in plain speak. Let's just say rather than file, we have house. Okay, rather than file, we have house. We all know what a house is. So we can say in English, house, my house, equals new house, my house, which is basically saying, build me a house. Okay, that's basically what we're doing here is we're saying, build me a file. And actually, we're not building it, but we're preparing to. So this would be like us walking up to an architect and saying, hey, architect, house, and we point to a house, and we point to me saying, my house, and we say, new my house, which is kind of broken English, but programmatically that's saying, I am going to build a house. In line 7, we're going to build a file, and it's called bob.txt. Now what we get to do is we get to write it. So let's do the following. We will say, how about the following? We'll put it in an if statement. We'll put an if, and we'll put in my obj dot create new file. Pardon my misspelling. Create new file. I think I got it there. I'm missing one of these. And we will say system.out.println file created. Look right? Yep, it looks about right. I actually have one error in here, but I'm going to kind of pause it there. I believe this is okay for now. If I need to do more, but I'm going to pause here for a second and let you kind of look at it. So talk amongst yourself. You're going to hear about 10 seconds of dead air. So you can pause the video or just enjoy the 10 seconds of dead air. All right, that was about 10 seconds. So what we're saying here again is, in our if statement, remember our if is a true or a false, and create file, if it's successful, will evaluate to true. Looks like I'm missing one of these. There we go. This will evaluate to true if the file is created and false if it's not. So this is a branching statement, which you should be familiar with. Remember, so you're getting to see here that branching statements aren't always if I is greater than 10. If you remember, in the if here, this is an expression that evaluates to a true or a false. So true means that the file was created okay. We get file created. Now we're going to get an error. If you got ahead of me and you're running this, I can feel you through the internet ether saying, Bob, my program doesn't work. We're not done yet. Remember, we got this exception thing. Okay, let me just go click on execute. Now you get an error here. Now it's kind of small, but I'll read it to you, right? Unreported exception, IO exception, must be caught or declared to be thrown. Now, if you're me, you know exactly what that means. If you're not me, well, you still might know exactly what that means. But if you're you, you have no frickin' idea what that means. Remember, we talked about exceptions. Exceptions are runtime errors. What Java does, and a lot of other languages do this, not just Java, what a lot of other languages do is they force you to handle some of these runtime errors. What this is telling you in English is, all right, Mr. Software Engineering dude or dudette, you're attempting to build a file. Okay, there's a lot that could go wrong when you're trying to build a file. You can be trying to write over an existing one. You might not have access or security privileges to write this file to this server. There may be a file that already exists, or I don't know, the file's invalid. What if I did bob.txt. Mary had a little lamb. And her fleece was white as snow? The file name might be wrong. So what Java does, and many other languages, is they force you as a developer, me and you, they force us as software engineers to handle these. And that's what you're seeing here. Unreported exception, IO exception, must be caught. So this is where I'm going to have to tell you you can actually tune out a little bit here. Up till now, you were completely hyper-focused on me. Now you can keep one eye on me. Just watch what I'm doing and just know that exception handling is something that's a complete different topic that you're going to handle in an intermediate class or an OO class. So let me do the following. I'm going to put in what's called a try-catch block. And of course, I'm going to explain this to you, but what I'm saying is you don't need to know all of this in the next 10 minutes. I'm going to put in try. And then I'm going to put in, let's see, this is this. I'm going to put in a try. And let me indent a little bit. All right, so this brace here is for the if, and this brace is for the try. Let me get some code out here, and I'll explain what this try is in a second. And let me type in catch. I'll type in IO exception. And I'm going to put in an error has occurred. Give me a minute. I know I'm typing a lot of stuff here. And there we go. And I probably should indent a little bit better. But I have two blocks here. I put in what's called a try block, which you see here. Right? You guys know about blocks by now. You should. So, see, this is the if block, right? This is the try block. And this is the catch block. Let me explain to you what this is. What we're doing here is we're doing what's called exception handling. We do exception handling in a try-catch. Now, again, the good news is most languages use those terms, try and catch, for exception handling. So you don't got to relearn this. for C# or some other languages. Some do kind of use different words than try and catch. They're called identifiers. But when we talk about catching exceptions, we all know what we're talking about. So anyway, what this does is this try block is handled differently. What this does is this tells Java, in this case, the language, that we want you, Java, to handle this code differently. Since it's in a try block, we are saying, Java, there's something that could go wrong with this code, and we know that there's something that can go wrong with this code. So try it before you actually do anything. So Java does that, and if there is an I/O exception, which stands for input output, how do you know it's an I/O exception? Again, this goes with experience. This goes with you learn your exceptions as you need them. If you didn't know this, here's a good one. Let's just say I was writing a catch block for let's say I was writing a file to a share on a web server, like on Google Cloud, and I knew something bad was going to happen. I'm using plain English. I might not necessarily know, even me, what exception there is. I'd have to look it up. I'd say, okay, well, I'm not writing a file to my local drive. I'm writing one to Google Cloud, like S3 or something like that. What exceptions can I get? And then I would learn it. I mean, it's almost like a doctor has to go to the manual sometime, and a lawyer might have to look up a case. Software engineers look up exceptions. It's like, well, what does this one do? You might Google a friend or whatever. You don't memorize these. You learn them as you go. In the first few years, you'll probably memorize a few dozens of these, and then you'll just kind of like, I got to look the rest of them up. That's what we're doing here. I just so happen to know that I/O exception is the one. And plus, it tells me here, look, my runtime error says I/O exception must be caught. In English, Mr. Programmer, Ms. Programmer, you're trying to write a file. There's a lot that can happen. Put the code in a try block and then catch the error. Now, I'm going to try running this. If it's not fixed, we're darn close. So let me just do an execute. Pardon me. And I'm almost there. I got catch I/O exception. I'm missing probably a syntax here. I'm catching. I got to name my exception. So I'll just call this one Bob. Whoops. Don't want to do that. And I'm naming it something silly just to show you get to choose what you name it. But you could just use conventions and call it E for exception. You don't have to. You probably should. It's a convention. It's not syntax. Okay, good. So let me execute my program. And you get file created. Woohoo! So what did you do? You wrote. Well, I did it, really. You watched it, but we'll pretend like you're here with me, right? We'll give you credit for it. We'll give you an attaboy and an attagirl and an imaginary extra credit bonus point. You wrote a very succinct, short to the point program that writes a file. There's nothing in the file, but if you look out on your network drive or wherever it is on your system, you will see a file called bob.txt. There'll be nothing in it, okay? But you wrote a file. Well, what are we going to do now? Well, I mean, now what we do is we, find a way to put something in it, make it more meaningful, or move it around, or delete it, or move it from folder to folder. What do you want to do with it? But you wrote a piece of software that wrote a file. Now, that's an accomplishment because you've learned a little bit about I/O here in about 30 minutes. And like I said, for something that's really a confusing topic, even to me, it is, because there's things that overlap, there's things that are missing, there are things that don't make sense, there's things that kind of do the same thing. And I'll look at them and sometimes I'll even scratch my head, especially when a new version of software comes out. I'm like, I wonder if they ever fix this stream I/O thing where there's I'm like, nope, it's still weird. So you've learned how to write a file, which is taking a step forward and learning I/O and getting your hands around a first working example. So please reach out to me with any questions, comments, complaints you may have. And in your spare time, play with this. Start looking up some documentation, and get your hands dirty. Start going through some examples and seeing some online videos on how this works. Now, as I usually say, and I'm going to say it again, there's so much out there on this material, on writing files, reading files, moving files. Oh, I have a Mac. I don't know how to write a file on a Mac, and this looks like it's a Windows thing. You're going to find it. The web is choking. That's probably a horrible expression. The web is chock full of good examples on how to do this. So I'm not going to read them all to you because you could find them on your own, but I can answer questions for you. So thank you for making it this far. If you watched the whole video, thank you for doing this example with me. And thank you very much for your time. And if you have any questions, please reach out to me. Thank you. And I bid you all a very well rest of the day.